All right, it is Monday night. Just uploaded the video showing the flooding and stuff, and it's about 8 p.m. or so. I was back out here working a little bit, and so I was cutting out the next set of. I did the CAD work in there. I was just grabbing something to eat and tweaked this a little bit. I brought this top section up higher, a lot shallower recess, only a 1-inch recess there for the beam. And because it left so much space here, I just put just a square in there to, kind of, I don't know. Ask Greg Porter if you want to know something about architecture. I don't know. I just kind of put some squares here, put a little couple things here and there, and then see how it works out. That's how I do it. But as it worked out, when I added the extra height, I was real concerned about whether I was going to be able to get 4 nested in there. And I got lucky. This sheet is, you can see there, about 48 and an eighth or so. And but as it turned out, I could have gone a little more aggressive here. Probably got an 1/8 of an inch or 3/16 between each one of those that I could have scooted it up and allow myself some extra room. But you can see where it cut the, yeah, you can see like right there. I mean, it just barely was fitting it in there. It was the same thing up here on this, kind of cutting it close there. But I was just showing you some close-ups. I think it was E. Formance Perry that was asking about the torch height control and sensing. It does the torch height control by voltage when it's actually cutting, but the reference, it's got this little mechanical plunger here. When it goes down, references off the plate, and that's where it senses the bottom at, and then it raises up by the distance that you set the pierce height, and of course from there it adjusts to the cut heights, and then as it's going, it uses torch height control and the voltage, and the closer it is to the material, the lower the voltage is going to be. So it will start to raise up, and the further away it gets, the higher the voltage is going to be. So it'll sense that and lower it down. I don't think it's very sophisticated. Just kind of watching it, it does adjust itself, but it seems to be slow to react. But you can see it did a nice job on this. I'm really pleased. Like, for example, this outer cut, the outside edge all the way around, and then makes its way back home. And there's the lead in and lead out, and you can see it, at least to me, it appears to have met back up. Maybe it's off a little bit. Let's see. I'd have to put a straight edge on it. It looks pretty well like it's meeting back up there. So anyway, just showing you guys that. And I was also thinking too, like, on the let's see if that was hot. You see that edge there? It's got just that rippling that's annoying the crap out of me. It's not bad, but it just would be nice if that wasn't there. I know I see a lot of other plasma tables, the plasma cams, and those that do not leave that at all. And especially when you get to the thicker stuff. But I was wondering, I have to go back and look. I think these things came with servo motors and not steppers. But if you've ever felt, a stepper running at a really low speed, you can actually feel the steps, and like on thinner stuff, you're running at 200 inches a minute, 300 inches a minute. It's flying, but it really doesn't jog that fast. So I may play around with that some and just set it up for 400 inches a minute on a dry cut or no cut, with the torches off, and just let it run like that and feel it and see how it's doing. But anyway, it's Monday night. This will go into tomorrow's video. I was just kind of showing you guys that. All right, guys, see ya. We're gonna run it at 400 inches a minute, and we're gonna select this dry run, which you can use in mock to just kind of do a dry run and without it actually cutting, and see what's happening. But you see I got a mag back indicator there, and I've got it zeroed out and a little bit of a preload on it. So I just wanted to check a couple things. One, just is it smoother when it's running at a faster pace? And two, does it run back? Does it come all the way back to and zero out that indicator right there? Let me just double check that and make sure it's just actually it's not quite dead on. It should be right on zero there. So we will zero out our X and Y and go ahead and cycle start this. Looked like it moved over. I don't know if it did or not. That was weird. All right. So with all that back and forth, it's looks like about 1.5 thou there. I don't know if that's good or not. I don't know if anybody else has tested their table out with a chain drive. It seems like that would be pretty good. Seems like it'd be pretty good. I need to do something where it comes out and then goes over there and comes back and then comes back over here, like to engage the X and Y. But I'll keep messing with it and see what we come up with. But if that's what it's doing, to me, that, you know, on anything plasma cut, that's going to be a really good tolerance. In fact, on those plates for that crane, we got the job, which I keep mentioning that. I don't know if I sound like I'm bragging or not, but got to eat around here, you know. But anyway, I did call them today, and they said, nah, there's no tolerances listed on the blueprints. And they were like, yeah, don't worry about it. Just, you know, it's just a crane. It's going to be outside, and, you know, just as long as it's somewhere in the ballpark, it'll be fine. So kind of happy to hear about that. It'll be interesting to see how that cuts and how close, because several of the parts, they're getting multiples of them to see if it's consistent from part to part. In fact, even these, when I pull them off, I'm going to stack them up and see if they're close. Because when I did those, they were not the same at all. Not even, I mean, 1.5 thou is one thing. These were like 1/16, in some cases 1/8 of an inch variances here and there when they were stacked together, and the holes didn't line up, you know, things like that. But that was before I made a lot of changes to it, including the tensioning of the chains originally. So, all right, guys. All right, so doing a little chemical stripping of the mill scale this morning, and I got a couple of brackets in there. This new table base that I cut last night that you saw in the video so far is going to be, you know, a bright, it's going to be just bare metal with a, you know, some kind of finish on it. But I want it to be the bright, you know, sort of shiny looking stuff instead of the gray, dark mill scale, which is, you know, the mill scale's got a good look to it as well, just clearing over it or putting wax on it or whatever. But this particular one I'm doing this way. So this is kind of what it looks like when you get it out of the muriatic acid and just rinse it off to deneutralize it, or to neutralize it. And one of the beautiful things about the muriatic acid, or the, you know, removing it this way with the acid, is it pretty much eliminates all the mill scale, I mean the dross on the back. You can just see a couple of little spots, a little bit hanging on right there, but whatever's there, it'll just kind of flake off really easy. Well, I don't have shut your face garage level fingernails, but it doesn't take much to get it off of there. And then here's one I just ran over with a Scotch-Brite disc just to kind of brighten it up a little bit. And then I'm going to likely, once I get it welded, going to finish it with, yeah, I know, I got a big mess in here. Crap just everywhere. Finish it with this shark-hide metal protectant. Works pretty well. I've used it a couple of times, and my first experience with it wasn't that good, but the last couple of times I've used it, it's worked well. So that's what I'm working on today. And so these are going to be the table base for that cedar, and a beam that I'm going to make here sometime, hopefully today or I don't know when, but I got these little shorter pieces. I'm going to make something up that'll hopefully look kind of cool. But you can definitely see the notch here, you know, that I left for the beam to go through, pass through, it's 1 inch compared to 4 inches on this one. And the impact of that is it's just going to raise the table up without having to have such a tall beam in there, which I think is just overkill for this, you know, for this setup.